Maple has built-in support for 38 different statistical distributions. And in addition, you can also build custom distributions by combining existing distributions or just by giving the formula for something like the probability or cumulative distribution functions. In this video, I'm going to walk you through a list of some of the available distributions, as well as showing examples taken from a few of these. And I'm also going to show some examples on how to build some new custom distributions, both from data, expressions, and other distributions. But to start, what I'm going to do is I'm going to open up two math apps, and these are both available within our math app guide in Maple. So the first one I wanted to show is our math app for continuous distributions. So just as a reminder, continuous distributions are really where we can get any value in our sample within a given interval. So this could include something like the number of hours of sun during this next summer. Whereas with discrete distributions, we have a finite number of distinct values. So as we can see here, here's a list of the most common distributions from our continuous distribution offering. And within this math app, you can actually use this math app to do things like explore these distributions and look at some of the key quantities. So here we have the Cauchy distribution up, but let's open up we'll look up normal to start with. So here's our normal distribution. Here we can see the PDF as well as the CDF down here for this. We can go through, we can have a look at a couple more here. Let's have a look at the student t distribution. And we'll look at the power distribution. And there's lots more after that. If we go over to the discrete distributions math app, we can do the same thing. We can look at some of the different offering in this list here of the discrete distributions which are available. And below we can explore each one. So here's, for example, the hypergeometric distribution, as well as the associated probability mass function. And here we can even customize this if we wanted to. If we wanted to enter in different values here and update this, we can do so. So that's just kind of a very quick introduction. That's just kind of very quickly glazing over all the different distributions you have available to you inside of Maple. But now let's actually jump over and actually start using a couple of these. And we're going to use a couple of these both through programmatic as well as clickable means. And usually what I would do here is I would load up our student statistics package. But in this case, I'm going to load that. I'm also going to load our statistics package. And the reason I'm going to load the statistics package is just get a little bit more access to the abilities to generate custom distributions and so on. So to begin with, let's just kind of go back to basics. Let's talk about really what a random variable is. And we can kind of conceive of a random variable as really being a way to map outcomes of random processes to numeric values. So say if we had something, we call it our process, in this case, X. And I'll just use something from our palettes here for a second. I'm just going to go over here, go to our expression palette, and just use our piecewise declaration here. So say X was values for flipping a coin. And say if we had a value of 0 if heads and 1 if tails. So this is clearly, as we mentioned before, this is a discrete random variable. We can have just two values here. Either it's 0 or 1, and there's no in-between value here. And basically this is just kind of getting us on that path of starting to quantify these random processes, starting to quantify these actions which are happening. So I won't spend any more time on this one, but let's move on and we'll do another example. And let's, for example, create a new random variable. We'll take this from a normal distribution. So to do so in Maple, what we can just do is we'll type in, we'll again use X in this case. So X is going to be equal to a normal random variable. And what we specify is the mean, which in this case we'll just use is 0, and the standard deviation, which is 1. Hitting return will now return our random variable object. And once we have this, we can start to look at various characteristics of these random variables. So we can right-click on our random variable, and we can go down here to Student Statistics, And we can confirm again that our mean is 0 as we would expect it to be. Same thing with standard deviation is equal to 1, which of course we just declared each one of these as being 0 and 1. But then we can also do more interesting things. We can right click on this and we can generate a sample if we wanted to. So say if I wanted to generate a sample of size 10, we can do so just by using that right click menu. So let's generate another random variable. We'll take another one from a different distribution. So we'll call this one y, and we'll take this one from a beta distribution. Now in this case, let's do this one, let's declare this one as symbolic. So we'll use beta's regular values. So we'll use nu and omega. So just to as a reminder, the first argument here for beta is our first shape parameter, and the second one here is our second shape parameter. So we'll declare that, and again we get back our random variable object here, R2. And once we have this, we can now more interestingly go on and find things again like the symbolic mean. So let's go on and find the mean. So here's the mean for the beta random variable distribution. Let's find some more key quantities here. Let's find the standard deviation. And as the last example, let's also right click on this in order to generate our PDF, and we'll generate the PDF at value t for the beta distribution, and we'll also do the CDF too. Same value t. All right, so basically once we have declared a random variable object inside of our environment, we could just quickly and easily just right click on these in order to pull out some of the key quantities to form PDFs, CDFs, as well as doing some visualizations, just all through those right click menus. Let's do another example, this time taken from a Bernoulli distribution with chance or probability of success. We'll just use P. And to begin with, let's do a probability function at the value of 0, we'll say. So the value for the probability function at 0 is going to be equal to 1 minus P. And accordingly, if we did the same thing for probability function at value 1, we would have the probability function equal to P. We can do some more computations here. Let's grab the mean of this, which is also going to be equal to P. And we'll do the variance, which is going to be equal to P times 1 minus P. And if we continue this one, so say if we just do Z is Bernoulli random variable with probability of success 1 over 2. We can then also plot the probability function using the same command. So properties, probability function at, say, a value, we'll call this x, and we'll generate a plot. And here we can see is the probability function for these two values. So here is 0 and 1, each with probability 0.5. So for my final example, I want to show you how to create a custom distribution. So in this case, I'm going to start by typing in my PDF is equal to, and again, we'll go back and we'll use that same trick as we saw before using the expressions palette to just open up a piecewise function. So it's going to be 0 from any value less than 0. And we'll do cos of t for t is less than, we'll do pi over 2. And then we'll add in another line. I just did use Control-Shift-R to add another line there. And we'll do 0 otherwise. So that's the PDF for my new custom distribution. So now let's actually generate our new distribution. We'll call this new distribution. And what we'll do is now we're going to use some commands from the statistics package. So we're going to do distribution. And we're going to specify that the PDF for this distribution is going to be equal to unapply. And this is just making a procedure out of my PDF up here of my PDF. And we'll just give this the argument t. And now say if we wanted to generate a new random variable based on our distribution, we could do so. We'll call this one w in this case. And w is going to be equal to a random variable. And again, we're using the commands from the statistics package in this case. And random variable based on our new distribution. So it's as easy as that. We've outlined what our PDF looks like. We specify the new distribution. We'll use this PDF. And then we declare a new random variable which uses that new distribution. So now once we have this input, we can go on. We can do things like find the mean we'll start with. So there's our mean of our distribution. Let's also look at the variance. And we can, of course, use this also to compute the CDF. We've got the PDF. We know that from before, but we'll do the CDF at value x, we'll say. And there's the CDF for our distribution. And we can also go on and do more things. Let's just use W again down here. And let's sample it. Let's generate a large sample. So sample of size, I don't know, we'll say 1,000 or so. Okay, now that I've got my sample, we can also generate a data summary of that sample. So go here, student statistics, and quantities, data summary, and return a plot. So we can see how this sample of our custom distribution looks.